Jones. I'm the farm manager at the Intervale Community Farm in Burlington, and I was interested in converting one of our older farm-all tractors to a DC electric system. We have a number of smaller, older tractors that we use primarily for weed control. Organic farms rely largely on 1950s and 60s mechanical technology for weed control. And the advantages of electric motors over old gas motors are pretty clear. There are some really nice torque benefits at low RPMs. You have infinitely variable speed. Sometimes we want to go very slow. And there are the added benefits of no fumes, a lot less maintenance, and a lot more sustainable fuel supply, at least in theory. So we had an electric tractor, and we were looking to turn one of our larger tractors into an electric unit as well.
Alright, so we have our solenoid here, which comes from the 72-volt system. When that gets energized, we energize the rest of the system. Attached to that is a 400 amp fuse. And then we have some relays here. One relay runs the batteries, or I'm sorry, one relay runs the hydraulic pump, one relay runs the lights. We have fuses here for our gauges. These fuses run our auxiliary components, such as the hydraulic pump, lights, accessory, and our 72-volt solenoid. We also have a fuse for our shunt. Here we have the potentiometer, which is the throttle for the DC motor. That's connected to the original hand throttle. Then we have our DC to DC converter. The DC to DC converter takes the 72 volts from the battery pack and converts it to 12 volts, or steps it down. It's like a transformer, steps it down to 12 volts and charges our 12 volt accessory battery, which runs the lights and the hydraulic pump. So here we have our key ignition switch, which turns the solenoid on and off. We have our hydraulic pump switch and our headlight switch. If we turn the headlights on, you can see we've got some nice bright LED lights. We also have our instrument cluster up here, custom fabricated with our battery gauge, our volt gauge, and our amp gauge.
The original gas motor, we also took out the hydraulic pump, and so we replaced it with a salvaged hydraulic pump from a Toyota MR2, which runs off of its own electric motor, and we hooked that up to our battery and hooked up the hydraulic lines to the existing hydraulic box, which uses the system that's already in the tractor to control the cultivating arms.
Okay, so to convert it, we used a DC electric motor. And we have 6 12-volt batteries giving us a 72-volt battery pack configured in series. And then down here we have the motor controller, which is attached to the potentiometer in the front, which then goes to the motor and controls the speed. Here we have the charger for electric charging, and the charger will sit right on the front when the front radiator is on, so it's easy charge.
First things we had to do was take out the engine block, and it was part of the structure of the tractor from here to here, so we had to come up with a subframe design to take the place of that. So basically we mimicked the bolt pattern that was on the engine block, put it on these 2 half-inch steel plates, one here, connected it with a channel iron. And here we designed another plate for our motor to take it out very easily, and this is the new structure of the tractor.
My name is Mike Daigle. I'm with Queen City Steel, and I've been helping these guys on the tractor. I am a farm-all aficionado and international harvester collector, and was originally against the idea of converting this thing over to electric. But I have to say, after seeing the finished product, they've done a wonderful job, not only mechanically, but aesthetically, getting it back to original condition. And I'd have to say, as an international collector, I'd be proud to drive it. They did a wonderful job. Good job, well done.